Namaste, I am Jayoti and Dr. Kiran Yadav. Welcome to the digital session of Jayoti Vidyapeeth Women's University. This session is for DET and DET+B.Tech third trimester. In this session, I will discuss about electric field at a point on the equatorial line of an electric dipole. So this is an electric dipole. There is charge minus q at point A and plus q at point B. The distance between the charges is 2a. The direction of P, that means dipole moment, is from negative charge to positive charge. So this is the direction of P cap or vector P. So any line that is perpendicular to this electric dipole and which passes through the center of this dipole. Okay, so this is a dipole, this is the center of this dipole, and this line that passes through the center of this dipole is known as equatorial line. So we will take a point P on this equatorial line and calculate the value of electric field due to these dipoles. So at P there will be two electric fields, one due to the charge minus q and second due to the charge plus q. Okay, so the direction of electric field due to charge plus q is this direction, E1, towards E1, this direction. Okay, because for positive charge the value of the direction of electric field is outwards, so this is the direction of E1 due to this charge plus q. Next, the direction of electric field at point P due to this charge minus q is this direction, which is shown by this by this arrow, and this electric field due to this charge is represented by E2. Okay, so in this direction there is electric field due to charge plus q, which is denoted by E1, and in this direction there is electric field E2 due to this charge minus q, which is denoted by E2. Okay, so both these electric fields have different directions, so we need to find out the resultant electric field due to these two electric fields. Okay, so what we do, we take the components, horizontal and vertical components of both these electric fields. Okay, so if we take this angle equal to theta, okay, so if this angle is equal to theta, then this angle will also be equal to theta. Okay, this angle will also be equal to theta. Similarly, this angle will also be equal to theta. Okay, because this is an isosceles triangle, if this angle is theta, then this angle will also be equal to theta, and because of this angle will be equal to theta. So both these angles will be equal to theta. This is a horizontal line at point P, and the vector E1 will make an angle theta with this line, and the vector E2 will also make an angle theta with this line. So the components of E1 and E2 in vertical direction, in this direction, will be E1 sin theta and E2 sin theta, but the direction of this will be upward and the direction of this E2 sin theta will be downwards. Okay, next, in this direction there will be horizontal components. The component E1 cos theta will be due to E1, and the another component E2 cos theta will be due to vector E2. Okay, so in this direction both the components are in this direction, so in this the total value of E will be equal to E1 cos theta plus E2 cos theta, which is sum of both the components. Okay, so here the charges are same. Okay, and the distance of point P from both these charges is equal. why I am saying that the distance is equal. So let me make you clear this thing. Let the point P is at a distance r from this point O. Okay, and the point OB is at a distance a, and the point A is at a distance a from this O. Okay, so this distance is r, this distance is a, and this distance is a. So in this triangle, if we use the Pythagoras theorem, then this distance BP is equal to square root r square plus a square. And again in this triangle, if we use the Pythagoras theorem, then this distance AP comes out to be square root r square plus a square. Okay, so we can see that AP is equal to BP. So the point P is at equal distance from A and P. And we know the formula for electric field is kq upon r square, where r is the distance of point from the charges. So in this case, both the points are at equal distance. So the magnitude of electric field will be equal at P due to both these charges. Means magnitude of E1 will be equal to magnitude of E2. Okay. So here this E1 which is the magnitude of E1, and here E2 which is the magnitude of E2, these terms are equal. So these both terms will cancel each other because this is in upward direction and this is in downward direction, and both the terms are equal. So they will cancel each other. Now electric field at point P due to charge plus Q comes out to be E1 is equals to 1 upon 4 pi epsilon 0 Q upon r square plus a square, and the direction of it is along BP. Second, E2, which is electric field at point P due to charge minus Q, is 1 upon 4 pi epsilon 0 Q upon r square plus a square, which is along PA. As I told earlier, E1 and E2 are equal in magnitude, but these have different directions. So the magnitude of these will be equal. From here you can see that these both have equal magnitudes, but their directions are different. Okay, so the magnitudes are equal. So the vertical components will cancel out each other and the horizontal components will be added. So the total value of electric field due to an electric dipole at a point on equatorial line will be equal to E1 cos theta plus E2 cos theta. This is represented by E equatorial. Okay. The direction of this will be in minus P cap direction. So here P cap is this direction and the resultant electric field is in this direction. So which is opposite to P. That's why we wrote here the direction as minus P cap. Here also E1 is equal to E2. Okay, in this equation also. So we can write E1 in place of this E2. So this formula becomes 2 E1 cos theta minus P cap. Then we write the value of E1 here, and then we write the value of cos theta from the figure. Okay, I will explain you how this value of cos theta. Okay, so from here this angle is theta, this angle, then this is base, this is perpendicular, and this is hypotenuse. So cos theta is equals to base upon hypotenuse. Here base is a and hypotenuse is square root of r square plus a square. So in place of cos theta, here we write a upon square root of r square plus a square. Then we further solve this equation. Here this 2q and a, which is 2aq, which is the dipole moment of an electric dipole, and which is denoted by P. So we, in place of 2aq, we write here as P. So we get this formula for the electric field at a point on the equatorial line of the electric dipole. This is the final formula. Okay, and in this case, if A is much less than R, then we can neglect A. as compared to r. So in that case, in denominator we will get r square, which is to power 3 by 2, which is equal to r cube. Okay, so then the value of E becomes equal to this relation. Okay, E is equals to minus 1 upon 4 pi epsilon 0 P upon R cube. Okay, there is another relation which we can get is E axial is equal to 2 into E equatorial. Okay, see the formula for E axial and you can check whether this relation is correct or not. Okay, so this was the formula for the electric field at a point on the equatorial line of an electric dipole. If you have any doubts, please mention in the comment section. Thank you.